Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're going to look at a facet of probability called two-way tables and two-way frequency tables. And we sort of got into these when we did the last example from our last lesson, independent and dependent events. We looked at a table that displayed data for people who voted in a presidential election. It displayed not only who they voted for, but where the people were located from. So it compared who their candidate choice was compared to where they lived. And that's where two-way tables get their name, right? They're comparing two different types of variables. So we'll look at a variety of these problems throughout the lesson, and it's just a different way of representing probability. It's actually, I think, an easier way to see some things rather than just having probabilities maybe listed out or in paragraph form. A two-way table can give you a better visual representation of what's going on. So let's jump right in. We're going to start off by conducting a fake poll and then answering some questions about it. So it says, let's take a poll as a class. We will see who prefers math versus English. I am not going to get real-time feedback here because I'm creating this video by myself, but let me just fill in some numbers here. And obviously, I'm going to be biased towards the mathematical side, which may or may not represent the thoughts and feelings of whoever's watching this. But let's say there are 9 males that prefer math and 4 that prefer English. And we're going to let's do 7 females that prefer math and 5 that prefer English. Okay, so like I said before, a two-way table is useful for organizing data that can be categorized by two variables. Right, so here we're comparing both the sex of the student and the preference for which subject that they prefer. So we're breaking it down by male and female, but also by who prefers math to English. And this is going to actually give us more data than may seem apparent at first. There's a lot of different comparisons we can make here, and we'll break down what some of those are. So the first question is, what is the probability that a student chosen is a male that prefers math? So based off this table, if you walked into the classroom and there were all of these students sitting down, if you just randomly chose one, what would the probability be that that student was a male who prefers math? Well, pause the video and see if you can figure that out. Well, we know when we're trying to figure out a probability, we want favorable number of outcomes over the total possible outcomes. Well, the favorable number of outcomes here, there are 9 males that prefer math, and the total is just going to represent the total number of students. Well, if we add all of these numbers up, total students ends up being 25. 9 plus 7, 16, 5 plus 16, 21, 21 plus 4, 25. So we get 9 over 25. And we can just leave that as a fraction. If we wanted to write that as a decimal, we could. 0.36 would be our answer there. Either one is okay. This is what we call a joint relative frequency. It is the number in each category divided by the total number of values. So our category here was males who prefer math. We divided that by the total number of students. We're going to have 3 different frequencies that we look at. The first one is joint. It's not as important that you remember what they're called as opposed to understanding what they represent and how to find them. Okay, so again, it's less important to me that you understand that this is called a joint relative frequency than that you understand, how to come up with it. Because that's going to be more important in terms of really understanding these two-way frequency tables. Let me scroll down here. I'm going to have to actually erase. Let me remember those numbers though. And let me make this a little smaller so I can see almost everything. All right, so we had 9, 4, 7, and 5. Let's look at number 2. It says, what is the probability that a student chosen is female? What is the probability that a student chosen prefers English? So there's actually 2 probabilities you need to find here. The first one, probability that they're female. Second one, probability that they prefer English. And these are 2 separate ones. Okay, we're not looking at dependent events here. The second event is completely independent of the first. Okay, so again, if we think about favorable number of outcomes, we'll call this A. So probability of A, well, there are 12 female students and there are 25 students total. So probability of choosing a female would be 12 out of 25, or 0.48. Probability of choosing a student who prefers English, let's call that B. So the probability of B, there are 9 students who prefer English, and there, of course, we know that there are 25 students total. So 9 out of 25, or 0.36. So these answers are called marginal relative frequencies. And a frequency here is just a probability, right? The frequency is 12 out of 25 or 0.48 or 9 out of 25 or 0.36. So when you hear marginal relative frequency, you can just think, okay, that's a certain type of probability here. This is the sum of the joint relative frequencies in each row or column. Again, not as concerned that you remember the marginal part. You know, our first type of frequency was joint, our second type is marginal, and we have a third coming up. That's not as important as being able to figure out what these actual probabilities are, right? And you could do that without really understanding what they're called. Marginal relative frequencies, that being said, let's, kind of break this down. That's when we're going to be finding, the total number in a row divided by the total in the entire table. So all of the students that preferred English compared to the total, or all of the females compared to the total. We could do all of the students that prefer math. We could just do all the males. So we're just comparing entire rows or entire columns to the total number of outcomes, in this case, students. One more type of relative frequency. I do have to put that on the next page, though. If a student chosen at random is female, what is the probability that she likes math? So if a student chosen is a female, so we're assuming that the chosen student is female. We're not going to be looking at what the probability is that we pick a female. But if they are a female, what's the probability that that female likes math? Well, I was going to sketch this table again. 9, 4, 7, 5. Well, if we're only looking at the females, right, we're only going to be looking at that second column. Well, if we want them to like math, that's going to be 7 favorable. Let's actually just write this. We'll say this is event C. So probability of C, well, the favorable number of outcomes is 7. Now, we're already assuming that they're female, right? So the total is not 25 anymore because we're not even looking at the males. We're just looking at the total amount of females. So total here would be 12. So our probability of event C would be 7 out of 12. This is called a conditional relative frequency. It is the joint relative frequency divided by the marginal relative frequency. But really, all this is that we're assuming that something is true, right? We're assuming that the student chosen was female. So we're kind of eliminating a certain part of the table, right? We're not even looking at it. So in this case, we weren't even looking at the male column. So we were comparing something from the female column to the entire female column in general, right? 7 out of the 7 females out of the 12 like math. We could also do something like just look at the students who like English, right? Maybe let's say we assume a student likes English. What's the probability that they're a female? Well, then we wouldn't even look at the math row, right? We'd only be looking at the English row. And if we wanted to figure out, student who likes English there's no H in well, there is an H in English, but not where I wanted it. Student who likes English who is female. Well, there's 5 females who like English, and there's 9 people who like English total. So the answer here would be 5 out of 9. So we're only really looking at a specific part of the table when we do a conditional relative frequency. So we have joint, marginal, and conditional relative frequencies. The names of them, far less important than being able to figure out the actual frequencies, the actual probabilities. Okay, let's look at this first practice problem. So it says a poll was taken of the citizens of Redsville about whether they would prefer tax money to be used on a new basketball arena, a new library, both, or neither. Use the given two-way table to make a table with the joint and marginal relative frequencies. So this is a table like the one we looked at for math and English, right? There were 2 variables, whether how they voted, so yes or no, and what they were voting on, the library or the arena. That's a two-way table. We're now going to make a two-way frequency table. So let me kind of explain what that means, right? This table over here, next to the red arrow, that's showing us the total number of people that voted on different things, right? So this 21, that doesn't represent a probability. That says that represents 21 people who voted yes on the library and yes to the arena. If I look at this 57, that represents 57 people who voted yes to the library, but no to the arena. So what we're going to build is a frequency table or a probability table where the numbers that we put in our table represent the probabilities of that little square, right? So let's say if I put and we'll figure out what the exact number is, but let's say I put a 0.2 here. Well, that would represent that there's a 0.2 probability that somebody chosen at random voted yes to both the library and the arena. Okay, so that's what we're working with here. So let's go ahead and first fill out the two-way frequency table. So if I want to figure out what should go in this box right here, I need to figure out the probability of someone voting yes to both the library and the arena. Well, I know that there was 21 people who did that. That's the favorable number of outcomes for this box. Now I need to compare that to the total, right? So in essence, I'm doing 21 divided by the total number of people, which means I need to add all of these up. Well, if we do that, we end up getting 150 people total that were polled. That gives us a frequency or a probability of 0.14. Now, I'm going to just put 0.14 in the box to keep our table less cluttered. But again, I wanted to show you how we found that, right? We were comparing the total number of people from that box to the total number of people altogether. So 21 over 150. But to keep it a little bit more clean, we will just write 0.14. Pause the video and see if you can figure out what should go in all of the other boxes. I would encourage you to do these three first before you think about what should go in these total boxes, because we haven't really talked about those yet. You may be able to figure it out intuitively, but save the orange boxes till you finish the red. Let's pause the video, see if we can figure those out, and then come back and rejoin us. Okay, so if I'm going to now look at probability of someone voting no to the library, but yes to the arena, well, that's going to be 30 divided by 150. 30 divided by 150 gives me 0.2. If I then look at number of people that voted yes to the library, no to the arena, that's going to be 57 divided by 150, or 0.38. My last box to fill out would be no to both. That's 42 divided by 150, or 0.28. So if we drew a random person from the survey, we would know what the likelihood of them voting yes or no to both of these is. Right? There's a 0.2 probability that they vote no to the library, yes to the arena, and so forth. Now, what we also can add to these frequency tables is the column totals and the row totals, and then a total for the overall table. Well, notice what you get if you add all of these numbers up. What if you add all of these probabilities up? Take a second to do that. Well, you should get 1. Right? And that makes sense because it shouldn't be greater than 1, and it shouldn't be less than 1. Right? All the probabilities for this scenario should add to 1. If they added to something less than 1, then that means we're missing some option. Right? It would mean that there's an option that we haven't looked at. If they added to more than 1, well, then it just wouldn't make sense, because there can't be, greater than 100% chance of something happening, can't be greater than a probability of 1 of something happening. We know that probability has to be between 0 and 1, including both of those n numbers. Now, I think it may be intuitive to figure out what these rows and columns should be. Right? If I add down my columns, I'm going to get 0.52 here. Let's think about what that number represents. What does that green 0.52 represent? Pause the video, see if you can take a second to figure that out. Well, that's just the probability that someone voted yes to the library. Right? It's not discussing whether they voted yes to the arena or no to the arena. In fact, it includes both. Right? All that number tells us is the probability that if we randomly chose someone, they voted yes to the library. Well, the probability that they voted no to the library, that ends up being 0.48 if we add down this column. And that makes sense, right? 0.52 and 0.48, they also both add to 1. So our numbers make sense this way as well. Well, let's look at the row totals. Probability that someone voted yes to the arena. That is 0.14 plus 0.2. That gives me 0.34. Again, that 0.34 doesn't say anything about whether they voted yes or no to the library. All it says is that there is a 0.34 probability that they voted yes to the arena. As far as voting no to the arena goes, That would be 0.38 plus 0.28, which gives me 0.66. And notice if we add these together, they also add to 1. So not only can we look at the probabilities for individual options, right, like yes to the library and yes to the arena, this box right here, we can also look at, well, what's the probability they just voted yes to the arena or just no to the library? And this is pretty helpful, right? It's extra information that we're garnering. If you have data analysts working for certain politicians or something, or even for just companies, well, there's a lot of information that can be garnered from a table like this. Maybe somebody cares about only the arena, and they only want to know, okay, is the public in favor of the arena? Well, they don't even want to look at the library numbers. They don't care. All they want to know is the public in favor of the arena or no to the arena? So they would look at this number and this number, and they would compare them. Maybe there's someone who just cares about the library. Well, in that case, you would look at this number versus this number. Okay, so you can kind of pull what you want out of a two-way table or a two-way frequency table based on what your question is or what you came to the table to look for. Okay, let's answer some questions down below here. Let me get rid of some of this stuff to clean up our table a little bit. I may have to just do this over so we can see all the questions at one time. Okay, so we're actually going to just look at questions A through C. So pause the video, see if you're able to use one table or the other to figure out the answers or the probabilities to these questions. Okay, so question A says, given a citizen said no to building a new arena, so we're assuming that we're only looking at the no category to the arena, which right away means we are only looking at this row, right? Because that represents no to the arena. So given they said no to the arena, what is the probability that they also said no to a new library? Well, based on that row, the no's for the library represent 0.28. But that 0.28 is not the probability of, given they said no to the arena, they said no to the library. That represents out of everybody in the poll, right? Though that 0.28 represents people that said no to the library and no to the arena. So what we have to compare here is this 0.28. That's like our favorable, probability here. And then we compare that to the total probability. But the total probability is not 1. It's actually 0.66 because we are not even looking at the people that voted yes to the arena. The total for this row is 0.66. The total is not 1. So if we divide these two, 0.28 divided by 0.66, we end up getting a repeating decimal. We'll just round here. It says round to the nearest hundredth if necessary. We get 0.42 approximately. We'll change those to approximately equal signs. So again, this is saying if we only look at the people that said no to the arena, there's a 0.42 probability or a 42% chance that we pick someone who said no to the library. If you wanted to think about this in terms of numbers rather than probabilities, right, we could come over here to our table that has the actual numbers of people. Sometimes it's helpful to look at these things in multiple different ways. So I'm just going to fill this in real quick. So if we think about this question again, it says, given a citizen said no to building a new arena. So we are only looking at this row right here because that represents the people that said no to the arena. Well, there are 42 people who said no to building a library, which is what we're looking for. That's the favorable number of outcomes. Now, again, the total number of citizens who said no to the arena, which is what was given, is 99. So 42 divided by 99. If you divide 42 by 99, you do get approximately 0.42. So you can see that regardless of whether you have the frequency table, which is what we call this is called a frequency table because it gives us the frequencies or the probabilities. Or whether you have the table with the actual number of people or the actual number of outcomes, you can still answer these questions. There are some differences between these two tables. We probably won't go off on that tangent right now. We'll probably wait to talk about it in class. But there's some advantages to both of these, right? They don't both provide the exact same information, but they do allow us to answer the same types of questions. Let's look at B. It says, given a citizen said yes to the library. Well, right away, I'm going to figure out what column or row I'm looking at. Yes to the library is this column right here for our two-way table. So given they said yes to the library, what is the probability that they said no to an arena? Well, let's look at the frequency table first. Probability they said no to an arena, 0.38. Total probability of that column is 0.52, right? Because I'm only looking at the people or the probability that they said yes to a library. So 0.38 divided by 0.52, that gives us approximately 0.73. So if we only look at the people who said yes to a library, there's a 0.73 probability that they voted no for an arena. We should get the same answer if we go over here to our two-way table without the frequencies. Well, we're looking for people that said no to an arena, so 57, over the total that said yes to a library, so 78. 57 divided by 78 gives us approximately 0.73. So again, works out the same either way. Okay, part C. Is someone more likely to vote yes for an arena given they voted no for a library? Or is someone more likely to vote yes for a library given they voted yes for an arena? Explain your answer. All right, looks pretty complicated, right? There's a lot of different givens, there's a lot going on, but let's just look at our table, separate out what we need from what we don't need, find the probabilities and compare them. Let me erase these answers so we're not, I'm actually going to pull this question up for us so we have more space. Okay, so the first part of this is someone more likely to vote yes for an arena given they voted no for a library? So our given is that they voted no for the library. So we're looking at this column right here or this column right here. Well, we're looking at that column and we're looking for, is someone more likely to vote yes for the arena? We'll just call this probability of A. So probability of A, yes to the arena, is 0.2 over 0.48, because that is the total probability for that column. So 0.2 divided by 0.48, that gives us approximately 0.42 if we're rounding to the nearest hundredth. Now the other probability we're looking for is someone more likely to vote yes for the library given they voted yes for the arena. Well, the columns we're looking at here, or the rows, given yes for the arena, means we're looking at this row, and we're looking for yes to the library. We'll call this the probability of B. So the probability of B, yes to the library, is 0.14 over 0.34, because that is the total probability or the total frequency for yes to the arena. So 0.14 divided by 0.34 gives us approximately 0.41. Very close, actually, right? So it's actually more likely that event A happens, that somebody votes yes to the arena, given they voted no for the library. So I'm just going to justify it here. Since the probability of A is greater than the probability of B, and you can only write those out as long as you define what they are, right? So we did that up here just by doing some color coordination. So since probability of A is greater than probability of B, someone is more likely to vote yes to an arena given no to the library. Okay, again, we'll do some more practice problems in class, but hopefully this kind of gives you an idea of all the different types of information we can pull from two-way tables and two-way frequency tables. Again, if we put the word frequency there, that means we're looking at the probabilities, not the actual number of outcomes. All right, as always, enjoy the rest of your day, and we will look forward to seeing you next time.